Yep.
So this is the last class of week 3. We already covered Ohm's law, and in this week's lab we did connection of simple circuit with one light bulb. For those who didn't, probably feel very confident now in basic wiring. It's not that complicated as long as you know which one is hot, which one is neutral, and how does it go. I will take it one step further next week by wiring 3 light bulbs. And hopefully that will solidify the idea between the difference between series circuit and parallel circuit. Okay, so I'm gonna start again with simple concepts. What does it look like? What are those little squiggly lines? Resistances?
Yep.
Let's call them resistance 1. And we'll put a voltage source here. This is 2.4. And the current is going this way. Let's put this into the A, resistance. So we have voltage. We measured that yesterday, right? What was the voltage? Everybody got 118. Let's say 120. And we got amps, and we have resistances. So if you have to guess right off the bat from looking at the picture, what happens to the total resistance of the circuit?
Or decrease.
Would it increase or decrease?
Decrease.
Huh?
Decrease.
Why?
Because by the time it goes from
The
one,
resistance
the resistance.
will decrease.
Decrease.
Who have another opinion?
It increases.
Increases, right? Because it's gonna add up. You know, 1 obstacle, 2 obstacles, 3 obstacles gonna add up. So it makes sense that the resistance will increase, right? Increase. Which equals R1 plus R2 plus R3. Make sense?
Yep.
Any doubts? Okay. What do you think will happen to the amperage? So, remember when we said in parallel circuit the amperage divide? It does not divide. Does it divide here? No, it goes from one resistance to another. So what happened to the amperage? Yes. Thank you very much. Stays the same. Okay. Now, $10 question. What happened to the voltage? Who says drop? All right, it does drop. It makes sense. After this commercial intermission, continue. Dial 10 to 20. Do they still have that?
No.
Okay, so what happened to the voltage? It will drop. That's 120. The first resistance will take some, second one will take some, and voltage, and we'll see that in the lab.
Oh, that's right.
We'll go and measure and we'll see that it will drop. It will completely be used up. Which means we have the voltage, if we measure the voltage between here and here, here and here, here and here, so let's call this V1, V2, V3.
That's where I got confused.
It will drop. So this voltage will be used up. That means that V1 plus V2 plus V3 will equal 120. At the end here, you'll get 0. Imagine you have a big pipe and you have faucets in series. The first faucet will have a lot of water flow. Second one will have a little bit. Third one will have only a trickle, if any. Make sense? Got it? Don't nod if you don't get it.
You said voltage is going to drop.
Yeah.
But why if you're going V1 plus
No, it does not go back. If we add them all together.
Oh.
So the first one will get like 120. Second one will get 80. Third one will get 40, or at the end between this there is 0. Depending on the load. But it's gonna add up. So you're gonna have 120 over here coming in, then it's gonna be 80, 40, and 20, and if you add them up, it's gonna be 120. I will do that in paper, I will have you measure it.
So it divides by two.
No, it just keep dropping. Because we're assuming the resistances are the same, but they're not the same. So a small light bulb, big light bulb, a motor, so it's gonna drop, and at the end it will be used. So, and we say this is not a good circuit for putting loads together. You agree with me? What is this used for?
Safety.
Safety and what?
Control.
Alright, we are on track. Is there an E here? I give up. It's good. That's why I love Spanish. Things are written the way it sounds. Okay, safety and control. Very easy, very simple. We'll move on to a little bit interesting circuit. And we'll do the same thing, and we'll do it in the lab. We're gonna do 3 light bulbs in series. I'll have you see the slope, do the math to it, and see how it does concur with the paper. So parallel circuit. Let's draw one. 120 volts. And we'll say this one goes this way. Okay. Resistance. What do you think happens to the resistance?
It's parallel.
Okay. This is say the same.
Six, yeah,
Same with what?
current.
As the other two?
What is it different?
Doesn't increase.
It does not increase. Excellent.
Yeah.
Not steady. Something magical happens. That resistance will drop. It will drop dramatically, and the resistance, remember this, there's going to be a key element. The resistance of the total parallel circuit will be smaller than the smallest resistance in that circuit. I'm going to write it down. It's a trick, very nice. Some electrician thought about it, and that's why you have lower resistance drops. So if this is 1 ohm, 2 ohm, 3 ohm, you expect the total, if you do the math, to be what? Just by looking at it and basing this statement.
6.
No, what did it say? It will be smaller than the smallest resistance in the circuit. So what would it be?
One.
Huh?
Less than 1.
One.
It's gonna be less than 1. I'm gonna get either 0.9 or less. It's gonna be less than 1 out of the bat. If you get something more than 1, you did something wrong. Write this down. It's gonna be very good way to, if you have multiple choice, and they give you what is the total resistance, sometimes you can look at the multiple choices and see, okay, I'm gonna eliminate the ones that bigger than the smallest resistance. There is some math involved, I'm gonna do it in a minute, but at least you can understand that if the resistance is bigger than any of those three in that parallel circuit, something is not right. Does it make sense? Well, that doesn't make sense a lot, but there's a lot of math behind it. We just have to remember it the way it is. I don't want to go too much into the details, but this is how it works. Okay, so this is idea. If we want to talk about the amperage, what do you think will happen? Because let's look at the amperage. What happens to the amperage?
It splits up, so it'll
Yeah,
jump, right?
yep. It's gonna be going this way, and this way, and this way. So amperage will divide, will drop. So if we call this A1, A2, and A3. So the total amperage will equal 3 of them, because they divided, right? You add them back together, they come back to become A. That is A. So they come back again. So A equal A1 plus A2 plus A3. Okay, voltage. What do you think happens to voltage? For your answer, think of the voltage in all your receptacles at home and how they are connected. And if you go to every receptacle, what happens? Stays the same. So all the receptacles, all the appliances in your house are the same voltage. So the voltage remains the same because everything is connected in parallel. Everybody gets the same amount of voltage. So the voltage remains the same. So when you think of parallel circuit, think of your appliances at home and how each one of them get 120, even though they have different resistances. So voltage stays the same. Any doubts? Write it down in a card. Yeah, go ahead.
Why would the voltage stay the same?
What keeps spinning is the amperage, not the voltage. And it stays the same because, again, voltage will always equal amperage times resistance. So the amperage keeps changing. Okay, so if you get the voltage here, it's going to be A times total resistance for the circuit. If you divide it, it's going to be smaller. But the ratio between them will remain the same. So think of this. If you apply this to this circuit, you get 120. If you apply this to this circuit, because the resistance does change, right? It will change. And the amperage will be smaller or bigger. But at the end, if you put your multimeter here, here, or here, you get 120. Question?
Why? What's up with like, why would the amperage drop? Is it because it's dividing the...
Yeah, you can divide it. It's very, very simple, but do it 2-3 times, just try to remember the concept. Find a way to remember it, find your own way. I try to give some kind of examples, but this is what happens. And why is this important again? Because we gotta go and troubleshoot a compressor, a switch, a fan motor. We wanna know which one is out and what's happening and what is the resistance we're supposed to be getting. Okay? So, there you have it. One more piece that's very fun, to me at least, is how do we find the total resistance of this circuit. The book has many ways to do it. I have my own way. I'm not going to go through why it's done this way mathematically, but how does it come to become the smallest one in the entire circuit? It seems like magic, right? But there's a mathematical reason behind it. I don't want to bore you with it, unless you want to. Come to my office hour and explain it to you. But I will show you how it's done. Write the method in a card, bring it with you to the exam, how to do the process again.
When are your office hours?
Huh?
When are your office
So
hours?
it's posted on the door.
You can just tell me.
Take a picture, I don't remember.
How do you remember? It's not as big that you don't know.
Actually, it's here. So I have Tuesday, 11:30 to 12:30, Wednesday, 1:30 to 2:30,
Oh,
and
it's a
Thursday,
different time, right?
huh?
Yeah, you don't gotta go through the whole list, I'll just say.
It's only 3 hours. And I'm also available by email. Email me and I'll come. You go to Starbucks, you go somewhere else. You know.
Gotta buy you a coffee.
That's okay, I'll buy you coffee. Okay, so let's do this math quickly. No, let's take our time. It's not, we have 10 minutes. We don't have to do, we'll do a lot of examples, And I just want you to remember the steps. And after struggling with finding a way to make people remember it, I found this method. So if I want to find the resistance, the total resistance for all these parallel resistance, I'm gonna do this. This is how I start. I'll say R total equals R1 plus R2 plus R3. This looks like what? This is look like this one, right? Series circuit. So what I do for parallel is the first thing I do is I flip. What do I mean by flip? I get the reciprocal for each one of them. 1 over R total equal 1 over R1 plus 1 over R2 plus 1 over R3. That's what I mean by flip.
Wait, so that calculates the resistance?
Well, no, it's a process. That gives you the R. That's what you're looking for. Okay?
What's that?
Huh?
What's that?
Flip.
And what's T?
Total. Sorry. Things are very imprinted in my mind that I don't even see the symbol. Okay? So now I'll put the numbers. What is R1? It's like 1 ohm. R2, 2 ohm plus 3 ohms. Okay. Second step, divide. I'll carry on the same thing as is. Don't change anything. 1 over 1? 1. 1 over 2? 0.5. 1 over 3? 0.33. Okay, we're good. So we divide it. Then I'll do add. Keep the same thing. This will be 1.83. Okay, flip, divide, add, and finally flip again. So this is going to be our total equal 1 over 1.83 ohms, and I'm okay with this number. If you want to be generous, you can divide it for me. .55. So remember the steps, and I'll tell you what people always get wrong. So what people do not do is when they carry out here, they just put R total, not carry it the same way it is. So this is one of the biggest mistakes people do. Second mistake is when you get to here and you think that's the answer. And if you look at this answer, is it smaller than the smallest one in the circuit? No. So you gotta flip it. This will be the answer.
So
Yeah.
should we just ignore the top equation, RT equals R1 plus R2 plus R3?
You can, but just whatever makes you feel comfortable with this. This is something I did myself.
You're trying to break it down from
Yeah.
the beginning.
Yeah.
Flipping it just means adding.
Yeah. Write it on a card. Bring an example with you to the exam. I don't care. I don't want you to memorize the methodology as long as you know how it's used. So put an example that help you understand it in your own way. Then bring it with you, and whenever I give you a new problem, just follow your example. You have to understand the example before you can follow it, right? So, and This is it. This is what we need to know for parallel circuit. And the reason we need to know this is if I have resistances and one of them is shorted, let's say this one was shorted, and I measure the resistance that is higher than the slowest, and this is what I'm supposed to be getting. And I don't get that. I know one of those is shorted, and I'll go inside and try to figure out what's going on. So flip, divide, add, and flip again. There are so many things online you can, methodologies to do it, but I like to have steps and just carry on, but that's the way my brain thinks. Whatever helps you do it is okay. And in the follows one, there is another one with, you have a big equation, you add everything in the top and you multiply everything in the bottom. There's other ones in the online you can do. The book has a few examples as well. So we'll do many examples on that, and I'm not going to make it more complicated than this. 3 is enough.
You said that yesterday.
Huh?
You said that yesterday.
I did? No, come on. Let's watch that back. Everything is recorded, man. Maybe think of the other class. So this is as involved as gonna get for this course. So master this, and we're done with complicated iffy math. Use it, whatever you want. Use it. Not friends, not the phone. Use a calculator. Use a note card. Use. I'm more concerned about you understanding the concept, and when you go, you know how to do it, or you know what it looks like. You know where to look. You know, we're not here just to grind numbers, huh? For example, we have a quiz in 5 minutes. No exams. Exams scary, man.
No, so what are you talking about writing no card for the game? You're talking about that, like, after?
No, for any quiz. For this quiz, for example, bring a card or a sheet, put an example on it, put Ohm's law on it, put power law on it, whatever you want, you put on it. How about that? Huh?
Can it be any size?
Fine, go nuts. And we had a guy actually, we have the same thing in the engineering school, and they allow you one A4 or letter size sheet, and the guy would photocopy like the book in small little squares in that sheet. Maybe reasonable, and do whatever you feel like comfortable to do.
It's not a cheat?
Huh?
It's not a cheat?
That's what I said.
How it worked. That's too original.
Be creative. At the end, it's about understanding concepts. You know, whether you get it or you don't, it's not going to help you. There are exams that are open book, open notes. So you don't want that. I mean, it's good if you know how to do work. Okay. So we have 25 minutes. Okay, so any questions about this? I will repeat it again on Monday. We'll do a few examples. I'll have you do 3 examples. And you guys seem very smart and nobody's having any issues. But if you have, please don't hesitate to come ask me. It's going to be in quiz 2. It's going to be in the final. You're going to carry on. And when you do it in the lab, it's going to feel really great. When you go on, you find 0.53 and you go on immediately. Wow, it actually does work. It's very cool. And when you connect the resistances in series and you see at the end, hey, the last light bulb is not lighting up. And you measure and it's 0. Or something not enough to light it up. So you understand. And it's very interesting. Okay, I'll stop here. Thank you.